Hey guys, my name's Ben with Upcountry Electric. Today we've got a trouble call. We have a residential customer with a pretty comprehensive water feature on their property. It's run by 3 separate pumps, basically just high flow, low head pool pumps. And the customer hasn't used it in a while, they said, and apparently it's not working. They think maybe the motors had seized up again. All the pumps are kept down in a cistern underground and suck from an underground tank and then circulate the water to the top of a landscaped area, and then the water flows across like a small meandering brook back down into a collection area that goes back down into the cistern. Pretty involved system. I don't know who did the original install. We came in a few years ago and have been replacing pumps as they fail. We'll see what we can do when we get there. Hopefully it's something simple. All right, we'll see you there. All right, so here's the 3 pumps. 1, 2, and 3. The cistern is down here. Their power, it comes from switched receptacles that are controlled remotely at a control panel. We won't bother with switching them at the control panel. We'll just plug them in. We have 120 here all the time for these little boosters. So let's try running pump 1. It's humming. That's not good. Let's try pump 2. It's also humming. And then, oh man, we might have tripped the breaker. Let's try again. Yeah, I think we've tripped the breaker that feeds that constant outlet. Let's try and test it and see. So I just want to see if I've still got 120 on that test outlet. Put him in AC. Yeah, nothing, it tripped. It tripped trying to run pump 2. Okay, so we gotta go reset that breaker. Still tripped. No, it's still tripped. Yeah. I plugged in pump 1 and it buzzed a little, and then when I went to do the same thing on 2, I could hear it go, and shut off. So I had 120, but now I don't. There might be something inside that control panel. Yeah, if it into the constant 120. Yeah, and I've got my probes in it now to see with my meter. Yeah, thanks. All right, next step is to try and spin the shaft of this guy. Do that by taking off his fan shroud. Take off the fan shroud and then spin him with a pair of channel locks. So this plastic fan just has a set screw that keeps it gripped onto the shaft. This shaft here runs completely through the motor and the pump. So if we're lucky, we can pop him off like so. And then we should be able to put a pair of pliers on there and see if we can spin it and make it come free again. It could just be seized up. It needs to be broken loose. There we go. It's better. It's better than nothing. Oh yeah. Oh yeah, there we go. That feels... There's a little bit of resistance there. That's for sure. It might be too far gone. We'll just try exercising in a couple laps. Right. Oh wow, did I slice myself? Oh, I did. Oh, pretty good too. Dang. Nice little flapper. It's still binding a little bit, but it's freer than it was, so it's about as good as it's going to get. I'll put them back together. And see if he works any better. It's definitely a big improvement. Yeah, it even kind of coasts a little bit. That's a good sign. Doesn't just bind up right away. There's definitely one spot where it's stiff though, but yeah, that's a big improvement. All right, hopefully we're that lucky with the others. Here's pump number 2. So right then I'm not spinning the shaft, it's just the fan that's spinning around the shaft. It's definitely seized up just like number 1. Let's see if we can get the fan off. And override the shaft. Here we go. A little bit of grinding sound, but that was kind of how the other was too. Just want to put the fan back on. Spin it with that. Pull it out a little bit. There we go. Definitely rubbing a little bit. Oh my gosh. Oh, the yoga position that this requires. It's hard on my back. He definitely was seized up, and now he's free. And he's even coasting a little bit, so that's good. 2 out of 3. Put him back together. Okay, here we go with pump number 3. Oh, pump number 3 is free as a bird. We never did get around to testing him with the power. The power failed when I went to run pump number 2. But number 3 is good to go, at least. The motor's good. Might be a problem with his caps, but... So, now we can put all these back together, figure out why there's no power down here, plug them in and see if they work. First 2 should spin, but they might overload if there's corrosion in there, and the third one should work just fine. Alright, let's get the power back on. Alright, so we got test power back in these outlets. Let's see if we can run them just temporarily. Here's pump 1. good. Okay. Let's try pump 2. Yeah, this sounds worse. Sounds like a bearing problem. But it is moving water. We'll see if it trips on an overload. It is moving water though, but it'll probably trip its internal thermal overload. And then let's try pump 3. Sounds good. Moving a lot of water. Alright. Let's put them all back in service and run them for a few minutes and see if they trip or not. Otherwise, they might be alright. It's really just going to be a wait and see kind of thing. Alright, so we got pump 1. Three keeps tripping on a thermal overload. That's a bummer. Alright, so 1 and 2 are working good. But 3 is overloading, but spinning. Which makes me think it's either the centrifugal switch or the run capacitor is bad. So we'll open up its capacitor bay here and check those. Definitely a lot of moisture in there. That's not good. Let's short these out. Oh yeah, that one's toast. That's an easy test. Short him out. So when your capacitor does that, when you're trying to take it apart, it's a pretty good sign that it's lost all its dielectric. But we'll give it a try. Test it anyway. That's not a good sign. That's not a good sign. Alright, so we'll put our meter in ohms. Secondary function there. Capacitance. That says 294 microfarads. He's good. He's just lost all his juice. Put him there. Let's test him one more time. 96. Yeah. Interesting. Okay, let's test the other one. Okay, here's the other capacitor. Same thing. 20 microfarads. Yeah, he's good too. Interesting. Could be the centrifugal switch, but it's hard to say for sure. Alright, oddly enough, we tested out good. Capacitors are all fine. Could be the centrifugal switch. Well, let's try it. Sounds about the same. Yeah, there it goes. It's tripping. Tripping on thermal. Yeah. I don't really want to take this apart to get into a centrifugal switch right now. That's located back in here. I'd have to take the whole pump out of the sump, take the motor off, and get back down in there below the fan guard. That'd be quite a bit of work. We'll see what the customer thinks if 2 pumps is enough. All right, well, the customer is elected to, while I'm here, I might as well. I'm gonna go ahead and take this pump and motor out and check the centrifugal switch. All right, so let's isolate number 3. Go, turn off the bearing. Okay, so bearing looks good. So this, as it spins, these weights here throw out. It's held onto the start, and it opens out of the start circuit. That's good. Looks like it's running. Let's check continuity. That's good. These little feet right here look alright. How about underneath these? Look alright. Thermal switch. Windings. Definitely had water in there at some point. See it all on the bottom. All the water down there. Three, two, one. Sounds about the same. I want to see how many amps it's using without any flow. All I did in there was just clean up the contacts a little bit. Connections look good though. That is definitely full of water. Alright, let's see what our amps are. So dry run, no load amperage. It's good. 2.3, 2.2. Could it just be the pump is overloading? The tolerances within the pump. Alright. Could be. Let's put it back in the hole and see what it does. I don't see anything wrong here that makes me not want to reinstall it. So let's reinstall it. Alright, now to just put them back onto the plumbing, fire them up and see what the amperage is when it's flowing. Alright, we got the pump in place. Just need to bolt it down and prime it. Alright, whoever designed this was intelligent. They knew what they were doing. Automatic controls, automatic timing, low water protection, low water shutdown, a transfer pump to drain the cistern for servicing, a sump pump to drain the dry well if it gets overflowed and wet, automatic top-off float valves for the cistern from the municipal supply, and a hose for priming the pumps because these are suction lifts, so they have to be primed. Just have to be careful that the discharge valves are open so I don't overpressure this pool lid or it will pop. Okay, so here's the bottom one. Back here. Okay, so we're going to take water from there. We're going to fill down to the foot valve. Come over, fill the impeller, push through the check valve through open valves there. Let's turn on the municipal. It helps if I open that up. have a small drip leak down here on this unit. So let's see if we can fix that by tightening in a little bit. Okay, with the priming line on, I want to try and run the pump and see what it does. This gets complicated. I want to see amperage though. I have a theory the pump is overloading. Something to do with the impeller or some spacing with the impeller maybe. Something's up with the pump end because the motor end checks out. That's good. That just makes me think the pump is all that's left. There could be a tolerance within the pump. It's just a single stage. A tolerance that's changed or widened so that the pump is throwing more water than it's designed, perhaps. And I'm going to try and rectify that by choking off one of the discharge lines to attempt to reduce flow, but there's no guarantee that'll work. I primed it enough for it to take off running. Valves are open, we're on amps. Let's go ahead and plug it in. The initial inrush was very high, about 26 amps, but then it came back down to about 2.5, which is similar to what we saw earlier. So let's see if we can get it going. Alright, so we'll plug them in and see if the prime holds, otherwise we'll have to prime them again. It's sucking. See the water coming in. Amps are good. 2.8. So as the flow goes up, the amps are going to go up. Amps now, flow's increasing. Looks like it's primed, at least well enough to throw water. Yep, see the level inside is climbing. Amps are up to 3.4. It sounds a lot better. I think maybe we were looking at corrosion on those terminals that those spade terminals were plugged into on the centrifugal switch. Yeah, here it comes, now it's full. We're at 4 amps, 4.1. I think our nameplate is 4.6 or 4.4. And it even has a service factor as well, so we're below that. And it sounds a lot different too. It sounds way better. Nice. It actually sounds probably the best of the three of them. Yeah, now it's running great. Not tripping off at all. 4.4 amps. Perfect. Wonderful. I don't have to choke down any valves, so we'll just run it at full speed. So it's working. Best thing I can think is that it was the corrosion on the contacts of the centrifugal switch on the spade terminals. Otherwise, everything else seemed good. When we opened it up, there's definitely some water, signs of water damage or water getting in. Otherwise, it looks good. We'll go ahead and fire up the other two pumps and check out the waterfall and make sure everything's flowing nice. Figured them out? Alright. See you in the next one.